In this part of our series of CTS studies, we're looking at the meteorology considerations in our discussion leading up to our presentation regarding the catastrophic events of the flood of Noah's Day. We're going to focus, of course, from the biblical text and the landscape literatures as supplementals. One thing I want to point out about meteorology is in the last 100 years and 200 years, the science of meteorology has advanced greatly from the many centuries and millennia before that. The ability to examine our atmosphere as well as the hydrosphere over the last 150 years especially has enabled us to study it from a scientific viewpoint with the methods and tools of experimentation to arrive at some good formulas for calculating, predicting certain behaviors within the atmosphere, the vapor sphere, part of the hydrosphere, as well as the liquid accumulations of water on the earth and the solid accumulations of the polar caps and the northern and southern regions hemispheric. Today's class is CTS 101-07, and we're primarily looking at very basic meteorology. Now, what do we mean when we say meteorology? Meteorology is a science that studies anything that falls out of the sky, excluding man-made objects, of course. But meteorology could also include that in the case of satellite space debris, which is re-entering, and the meteorologist that does the reports will pass that on to the public as part of his weather report, because that's just debris falling out of the sky. So we're not talking about just things dealing with water, such as rain and snow and ice, sleet. We could also be including in that volcanic ash, debris, any type of substance or compounds which the atmosphere would allow to fall back or settle to the earth. So with that being known, we're going to discuss just a few basics. We're not going to do a whole lot of discussion about sublimation or any of these type of things. That gets into calculations, pressures, and this and that. In preparation for today's presentation, I went outside. I happened to be home in Bandera, Texas, actually Pipe Creek, and went out on my deck, and I sat in my easy chair and observed the atmosphere above where I was living on a typical summer afternoon day. And I began to look at the different cloud formations just to see what kind of things could be observed today. It is a hot day. We were up into the summer temperatures. But I was amazed. Every time I look upon God's creation, I am amazed at His handiwork. I mean, to look up into the sky, to look at the clouds, it's, I know I'm getting a little poetic here, but the beauty and the diversity of the artistic work of the Lord in nature just amazes me. Today I was able, in one panorama, to look at several different things which I could observe. As of course I was considering how the composition of the atmosphere and the definitions of the layers may have changed prior to the great event of Noah. Now, with all that being in mind, there's not a lot scientists can tell us about that, actually. So let's look at first a little poetic type of observation, which any of us can do on any normal day, whatever you want to call normal. First off, I was able to see some standing lenticular clouds in some of the higher elevations. There wasn't many, but I did notice a couple off kind of to the southern western sky, at about 40 degrees altitude from the horizon. They were very, very descriptive of the standing lenticular, which let me know that the wind speeds at that particular layer elevation level of atmosphere was probably up there pretty high. That there was pretty high winds at that altitude. Then I noticed in a few cirrus layers up very high. Of course, as we all know, cirrus is pretty much typically vapor which has went to the change of state, changed through its latent change, and went to an ice particle type of upper atmospheric cloud, usually associated with the upper levels of the atmosphere as far as the cloud layers are concerned. Cirrus clouds usually you find in standing lenticular type at the upper levels in regard to like your cumulus, those types. Also notice that there were some scattered clouds around the area, which were kind of transitional in their definition. I noticed that we had some small cumulus mixed in with, and it was kind of unusual where I was not to see some towering cumulonimbus clouds, but on this afternoon I didn't see any towering cumulonimbus, which we also know as the clouds that form the thunderstorms. And we know that they also, when you see one that's got the anvil head, they also not only produce thunder and lightning and rain, but the phenomenon we all know does damage to the car and hurts a little bit when it hits you, and that's hail. So there's quite a bit of diversity just going out and taking a look into the atmosphere. Now, first off, science in modern times has established a standard day based on certain measurements. And I've only experienced that I actually took note of it. Standard days are very comfortable, by the way. A standard day is when you have 59 degrees Fahrenheit and the sea level pressure is 29.9 inches of mercury. And that defines the standard day measurement. Why do we need a standard day? It's a comparison tool. It's a position on the scale of measurement that we can work from in order to do our scientific relationship, equations, calculations, etc. in the science of meteorology. Now, the science of meteorology can get very complex. And in truth, it can change so quickly as to where the situations can become very dangerous. We're all familiar with the events of tornado activity and such to where that even professionals, people in the scientific community who would get out and kind of, shall we say, challenge nature to become something like the tornado chasers, take a huge risk. They're dealing with dangerous phenomenon. And recently, we know in the news there was some 3 tornado chasers who lost their lives as a result of getting caught off guard in a rapidly changing situation in the weather phenomenon, which took their lives. Sad to know. We know that tornadoes go through and destroy cities. And we know of situations where they went through small towns. One that comes to mind, of course, is Joplin, Missouri. Not a real small town. A small town compared to some of the cities we know. But the tornado pretty much just devastated. Excuse me. My allergies are taking effect. I apologize for that. Devastated the city, took life, destroyed property, set people back in life. Tremendous tragedy. But nevertheless, we're dealing with nature here. So I could get into quite a bit of depth. There's one more thing I do need to mention about meteorology in quick passing here. Latent temperature change. A lot of folks don't know what latent means. Latent simply refers to the temperature measurement at which a particular substance changes state. And what is so significant about latent temperature? Now, I'm going to try to say this simply. Most classes break this down into both theory and labs, but try to understand this is an important phenomenon because of one thing. It's the amount of energy. When we think of energy, we generally think of heat transfer. And at latent position on the temperature scale, let's use water and ice. When water, under standard conditions and pressures, reaches a specific temperature for that particular pressure condition, water can, as you lower the temperature measurement, water will go into its latent change and become what? Ice. As we know, it also changes density. Now, at the latent change of state, that's what we call change of state. Water can also go through another change of state when you apply heat. Of course, this also varies with the pressure. And who can tell me that? vapor. And we can steam or vapor. As you know, the locomotives that were invented well over 100 years ago and put in and changed the industry of the nation. Major changes with the advent, let's call it the advent of the locomotive, the steam locomotive. And also, the steamship changed how the oceans were navigated and changed the industry. They went from the sailing ships to something that they could actually go against the wind with. And that tremendously changed the seafaring industry. And that depended on latent temperature change of water. And what that was is at a certain temperature, water which was stored in a tank could be pressurized and vented in such a way as to where they could use that latent change where it becomes steam vapor and apply that and put it into mechanical force, producing horsepower channeled through mechanical means to the wheels. And they could move heavy locomotives, pull tremendous amounts of weight across country, fueling it with a heat source, coal or wood primarily. Same thing with the shipping industry. And we won't go into the other things, but the idea is there we can apply the latent temperature. It applies to other compounds too, of course, hydrocarbon fuels and all of that. But the atmosphere, the reason I mentioned that, one more thing about latent temperature change. First off, something very significant happens at the change of state point. Someone want to tell me what that is? Okay, the calorie amount of energy that exchanges is released or absorbed, depending on which way you're going, tremendously is multiplied about 7-fold when you're considering water. Like whereas the calorie change between, say, a temperature of 51 degrees Fahrenheit and 52 degrees Fahrenheit is only a few calories per cubic centimeter. But at latent temperature change, let's use where it goes from water to ice or ice to water, basically around 32 degrees Fahrenheit, okay? At that point, or 0 degrees Celsius. At that point, when it changes temperature by only 1 degree measured temperature, as the water or ice, whichever, changes state, the ice to become liquid or the liquid to become ice, of course, there's a expansion factor or a contraction factor. But at that temperature, between 1 degree one way or the other, within that range, the calorie of energy which is exchanged is multiplied by about 7. See the significance of that? It's an energy phenomenon which was observed early and associated in the scientific studies, and it got the label of latent. So when you hear the term latent, it's talking about change of state. I know I stayed on that a while. It's very important. When we're examining the catastrophe and flood of Noah, we're going to be looking at some changes and quick changes, this direction, that direction. Tremendous energy changes in what I call the meteorological stir of events that took place during this time. And we're going to examine that. Now, in weather, there's another, meteorology, excuse me. We're going to be basically discussing water here because even though volcanic ash, volcanic activity, anything that falls from the sky, meteorites, anything like that back in those days, time from Noah basically, anything that fell from the sky, science would refer to as a meteorology event. So, taking that into account, when we're talking about an event described in the Bible scripture as a flood and waters, we're talking about meteorology and hydrocycle. Hydrocycle being the things on Earth, hydrocyclic stir, and meteorological event in the weather, basically. And all these things, I'm going to explain to you two things hypothetically, by hypothesis, that could have shall we say, a rather unique and exponential effect on the meteorological cycle considerations over a short period of time. What do we mean when we say a short period of time? We're talking about measured in the climatic standards, the times of climatic age, things like that. Anything that took place over a relatively short period of time. Say a wood year cycle, something like wood year, would be considered a temporal event. So in weather, there's a lot that you could look up just simply by going online and doing some weather study and running your references. So I don't need to go a whole lot further, I don't think, because I covered the basic points that you needed to know regarding energy exchange. Energy exchange is very important. The amount of energy, for instance, and also I think I need to go just a little further. Let's talk about Coriolis and geographic rotation of the Earth a little bit. Also, the heating path of the rotation of the Earth and angles to the sun. I didn't really want to go there, but I think maybe we should. First off, your what we call hurricanes and typhoons, otherwise known as cyclone storms. These are phenomenon of nature which generate tremendous amounts of energy. The energy exchanges and the way the energy interacts, this is the best example that I have to relate to you about what I call the hydrocycle stir or hydrocyclic stir. In the situation we're talking about, so let's use hurricanes. All of us who have lived along the Gulf Coast of the United States or along the eastern seaboard are very familiar with the threat of a hurricane. We're also very aware of the dangers that a hurricane could pose and the potential for disaster that they pose in certain situations. Something not to be taken lightly, especially when a hurricane appears to have a high level of active intensity, which nowadays with our observation tools, our satellites, our high-altitude aircraft, tracking systems, and communications, we can stay much better informed about the threat of an impending storm headed our direction and take action to try to be safer about how we either evacuate or how we prepare for the state. Now, about hurricanes, the things that affect, as you know, the Earth, the shape of the Earth as it goes about in rotation, as it orbits the sun. Every 24 hours it rotates around. That's a cycle, and not a day cycle. And every 365.4 approximately days, it makes a cycle around the sun called the orbit. Well, during the inclination times of the seasons, when the Earth is shall we say, when the Earth is at different 90-degree points going around its orbit to the sun, that's defines our seasonal changes. The Earth is tilted around 23 degrees to the shall we say, the path of its orbit, which we would call our latitude Tropic of Capricorn, Tropic of Cancer, marks these latitude lines. And as the Earth goes around, the Earth doesn't tilt back and forth, but its angle to the sun changes as it orbits the sun. And this is what causes the vertical track, shall we call it the lateral track, of the path of the sun in relative to the ground as the Earth goes around. So the sun is very rarely ever directly above our heads. It's usually at an angle, depending on where we're at in reference to latitude. So you can get into that study a little more. Just be aware that all that plays a factor in the seasons. Now, as we know, during certain seasons, as the Earth tracks around the sun, what's significant about that is how the sun heats the positional latitudes as it goes around. We're all familiar with the equator. The equator being that band of, shall we say, equinox, where the sun is equally spaced between the upper and the lower hemispheres of the Earth. And at the equator, when the sun is directly above, as the Earth turns there, then most of the sun heat is absorbed in those ocean areas as it goes around, and it produces a expansion in the atmosphere and a moisture absorption. Of course, it does other things too. It actually distorts the gravity of the sun along with the heat, actually distorts the shape of the atmosphere to where the atmosphere is much thicker as far as its height at the equator during that time than it is at the poles of the Earth, where the atmosphere the thickness of the atmosphere is much thinner. It also, the engine of the energy absorbed from the sunlight, most of it is reflected away, of course, and scattered in the atmosphere. Some of it actually is absorbed into the ground, and heat is absorbed into the conduction and also convection forces. And what we have is in the course of forming these low pressure, what causes it to rotate is the effect of Coriolis. As the Earth rotates, and as the storm tends to, what begins the storm, of course the depression, the low pressure area, begins to track along, moving upward or downward, depending. The rotation will be one way in the northern hemisphere, and it'll go the other way in the southern hemisphere. It's because of Coriolis. That's what causes that. What is Coriolis? Well, when you're talking about geophysical, which is what we're talking about Coriolis in relationship to Earth. Astrophysical Coriolis is a little bit different. But in what we're talking about in meteorology, we're mostly going to be considering, as far as hurricane goes, geophysical Coriolis. Coriolis, as the depression begins to track upward in the latitudes, the speed of the ground below the storm changes, and the changes as the storm is tracking at an angle as the Earth rotates, it begins to cause a spinning effect, a swirling effect on the storm itself. And this is where you get your cyclonic forces that begin to build up. And many other forces, including basically tremendous latent changes in certain levels and activities and speed. Velocity changes temperature, and there's tremendous velocity changes within such a cyclonic event. The temperature of the water below it, the friction action with the water below it, all of this has a contributing effect to the phenomenon we know as a cyclone, basically a hurricane or a typhoon. Now, why did I spend so much time? And we're nowhere near through. There's so much more that you could do. Of course, just remember, the driving energy is basically sunlight, and how the sunlight is handled or managed within the nature phenomenon of the atmosphere and the hydrosphere. And also other contributing motor factors, mechanical factors such as the rotation of the Earth. Big factors. And, of course, we could also consider the upper wind patterns and the lower surface wind patterns, making their long-distance trips to and from the poles. So, but we won't have to necessarily go there too much. But the point that I want to make clear now is we're wrapping up here. And understand we could talk about meteorology, weather phenomenon, and the things that affect it from now on. I want to close with one more thing as I finish the hurricane part. The reason I'm using hurricanes right now is my focus point in the subject. It is an example of a stir event. A stir event being driven by forces, multiple forces. Of course, the energy of the sun and how the energy of the sun is managed by nature, how it's handled by nature, how nature reacts to those energy exchanges going on, is the driving force that creates these monster storms. And we all know they are gigantic storms. I mean, they're a major thing. They affect the economy of our nation when they hit. They affect so many things, not including endangering lives. They sink ships. They destroy structures. They change lives. They're that major. But they are a stir event. Understand that they have a life cycle that is driven by events of nature. But there's one event that we're going to go into in our next subject that is not something that is a common event. When I say common, in our next class we're going to move over to what I call gravitational lensing. And we're going to also go to astrophysics in the sense that we're going to talk about what gravitation does to weather. And not only what does gravitation do to weather, but what inner core effects gravitational lensing could have on the molten mantle surfaces of the Earth. We talked about the levels of the crust of the Earth in our earlier class, and we talked about volcanology a little bit. And even under what we consider to be relatively normal gravitational lensing on a fairly normal, shall we say, routine, periodic situation of tidal forces from the moon, we find that gravitational lensing has a definite, measurable effect. It's undeniable. It's very easy for you. All you've got to do is go out to your favorite beach next to the ocean or the Gulf and watch the tidal forces. Those are an effect of the sun and the moon, primarily the moon, because it's closer to us and it repositions itself to us more often. But the gravity effect of the moon, I want you to remember, now we're only talking about the moon at this point. We're going to introduce hypothetics. Also has a tidal effect on the molten subsurface of the mantle of the Earth. In other words, anything that is fluid in the subsurface below the crust of the Earth that is not part of the lithosphere, but anything that is in fluid form, tidal forces have an effect. You just don't see them, except in the rare occasions when you have a volcanic activity. We don't usually associate that with tidal forces, but tidal forces contribute to what we call trigger conditions. Trigger conditions are when you have forces out of balance, where you have normal conditions that are in a state of stability. But what we call a critical balance condition is when the situation, if it is tilted either way of the critical value, stable value, then you could have something has to give. And in those cases, sometimes you have earthquakes, sometimes you have fault line shifts, and we know that there are many explanations and many contributing factors. But in our next class, we are going to go into the discussion about gravitational lensing. And the reason we're going to keep it fairly narrow is because the science of gravitational mechanics is very complex on the astrophysical level. And we're going to discuss it kind of like we did the weather. We're going to touch meteorology. We're going to touch on the highlights just so that you've got enough basic groundwork in this. And some of you out there who have studied the sciences on these matters already have all this preparation. But understand, I want everybody to have the basics. And those of you out there on our YouTube audience on this is primarily targeted to you today. The classroom discussion will go a little bit, take it to a little bit more in depth. But we're going to talk about gravitational lensing, and we're going to include it because I'm going to show you where I believe we actually have evidence that some great gravitational unique event took place that actually altered the stability of the velocity of the orbit of the moon. And that is significant evidence. Now, there are those that will disagree about the reason why the moon is accelerating. And there are those that will disagree about the reason why the moon's orbit is extending out further away from the Earth over time. Now we're only talking centimeters per year. And on the scale of the size of the Earth and the moon, that don't seem like something that's even measurable. But understand, for those amounts of variance or difference to occur, when you're talking about something of the mass density of the moon, to affect it in such a way as to where its orbit is destabilized even by that amount, you're talking about a tremendous gravitational influence. Something affecting gravity is what I mean when I say gravitational influence. Some say that's one of the evidences. Now, my certain colleagues in theology sciences, couple that I really like and actually very much admire their work and like their presentations, disagree about the evidence of a global flood. I believe there is evidence I just believe that a lot of it's not getting the credential recognition that it should. And I believe there is much evidence to show that, yes, there absolutely could have been a flood. I believe that the flood event is described in a way that's very simple. When the antiquities refer to water being upon every high mountain, I do not necessarily believe that every high mountain in the earth was submerged underwater. I do believe some were. But I believe water was definitely up on every high mountain. And that could mean a very severe storm situation, intolerable storm situation was slamming every mountainous area in the earth. Now, we're not going to get into the survival of species so much because we'll touch on it in our discussion of Noah when we get there. We're only 2 classes away from our beginning of the literature examinations of the cataclysm event. And I appreciate everyone being patient on that. We had to work through some sciences, and I really appreciate your patience in that area. God bless you as we conclude this very short class today on meteorology. You could spend a whole semester just experimenting with things to play with about meteorology. But just consider this just a little primer to sort of help kind of get some things in our head about the meteorological hydrocyclic stir of events that we're going to be talking about that took place at the time of Noah. And I'm looking forward to it. Our next discussion is going to be on gravity effects. So by all means, God bless and stay with us and come back for our discussion about the gravity considerations. Farewell.